Hey guys, welcome back. Today I'm going to show you real quick how to implement a normal queue in C with the help of a structure. There are primarily normal queues and circular queues. In this program, we are going to code a normal queue and you'll soon enough know the main difference between the two of them. A normal queue has a certain disadvantage which gets rectified in a circular queue. Alright, so without wasting much time, let's get started. I hope you all know the theory behind a queue. If not, I'll give you a quick briefing. So in a queue, you have your front and your rear. You add data into your queue through the rear and you take data or data leaves the queue from the front. We can also call it a first in, first out mechanism, exactly like how it is in real life. When you're standing in a long queue, you join the queue from the back and people who are ahead of you leave the queue before you. All we're doing is copying this functionality and putting it into code. Alright, so let's start with the program. First, we have to include our header files, as usual, stdio.h and stdlib.h. Next, we define a structure called queue, and inside it, we declare our variables, which we will be able to access globally in this program. We access these variables with the help of a structure variable. Unlike my previous video, where I implement a data structure with an array, in this we will use a pointer to integer and use that instead. Don't get worried when you see a pointer, there will be nothing complicated involved. Using a pointer instead of an array makes your code much more efficient while providing the same functionality. I will explain why using a pointer is much more efficient later in this video. Other than that, we declare a variable called front and a variable called rear, which, as mentioned before, will keep track of the first and last element in the queue respectively. Next, I declare a variable called size, and as the name indicates, it will hold the size of our queue. Finally, I declare the structure variable with which we will use to access all these variables inside the structure. Let's now go on to our main function. Just like how we implemented the stack in our previous video, the main function we will be using is pretty much the same. We first ask the user to enter an option. The user may choose to enqueue, which is to add data to the queue, dequeue, which is to receive data from the queue, to display the queue, and last to exit from the entire program. We receive the option, which is an integer anywhere between 1 and 4. This is because we have a total of 4 options. We take the user's input and put it in a switch case. I'm going to start off with case 4 since it's to exit from our main program. And this is also because the control doesn't have to go through the entire code if you want to just simply exit. Also, we don't need a break statement after exiting because, well, we're exiting from the program, so putting a break statement after it is pretty much redundant. A default case is written at the end, and this displays invalid option in case the user enters some other number which isn't in between 1 and 4. In case 1, we will ask the user to enter the data they wish to enqueue. Once we receive, we call the enqueue function and pass the received data onto it. In case 2, we call the dequeue function inside a printf, so we can not only dequeue the data, but also print it onto the screen. Finally, case 3 is to display our entire queue, so we will call the display function. After that, I put everything that we just did in an infinite while loop because we need to keep getting prompts on the screen until and unless the user wants to exit. I finish off the main function with a return 0. However, our main function is not over yet. We still haven't initialized the variables inside our structure, and we will be doing that next. And I do apologize for the chicken in the background. Remember how I said that using a pointer to integer is much more efficient than using an array? Well, here's why. In this program, we are going to let the user decide exactly how big they want their queue to be. And we can only do this if we use a pointer. Through dynamic memory allocation, we can specify exactly how big our queue will become depending on what the user inputs as size. This way, there is no wastage of memory. So we ask the user to input whatever size they want their queue to be, and we then initialize the pointer variable inside the structure with the help of malloc. To check if the memory allocation was successful or not, we put an if condition and check if our pointer is a null pointer. If that is the case, then that just means we have run out of heap memory and the program will end there itself. However, that rarely happens. We also have to free the memory we allocated once we are done with our program, and for that we use the free function at the end. Next, we carry on and initialize the remaining variables which were inside the structure. We initialize both front and back to -1, as that is a standard condition which indicates that our queue is empty. Let's now move on to declaring the several functions which we will be using in this program. We have the enqueue function, which is of type void, as it will not return any value. However, the function will accept a value from the user, so we pass a parameter of type int. Next, we have the dequeue function, which is of type int, as it will return the value which was dequeued. We also declare the display function, which will be of type void, as all it does is print and will not be returning any value. Finally, we have two more functions: isFull, which checks if the queue is full, and isEmpty, which checks if the queue is empty. You can also call them isOverflow or isUnderflow. I chose full and empty for simplicity. Both of the functions will be of type int, as they will return a 0 or a non-zero value depending on the condition which we put inside. After this, I quickly compile my code to check for any errors up until now. It is a good practice to check your code at each step so that you don't get overwhelmed with errors when you check everything all at once at the end. You can also check for any logical errors that you may have made up until that point. Over here, I put a colon instead of a semicolon after one of my breaks. I also forgot to call the exit function for case 4 in my main function. The next step, we move on to the main part, where we define all the functions we declared and used in the main function. Let's start with the enqueue function. First, we need to check if the queue is full. If it is full, we won't be able to push any new data onto it. So we print a condition displaying failure. We check if it's full with the help of the previously mentioned isFull function, which we will soon define. If it isn't full, that means we can push. Let's check the logic involved. There is a special condition which we need to consider while pushing data, and that is the initial condition when the queue is empty. Pushing an element into the queue when the queue is empty means that we are actually pushing our first element. This means that we need to increment our front variable as we are receiving the first element in the queue. We also have to increment our rear variable, as remember, data always enters through the rear, so in conclusion, when there is only one element in the queue, it means that the single element is both the front and the rear. Furthermore, in all cases, after the first element is pushed, we should not increment our front variable. Rather, only the rear variable should be incremented. Coming back to the program, to check if we are entering the first element of the queue, we check if the front variable is -1. If it is, we increment our front variable. Next, we add the element given by the user into the queue at the incremented position of the rear, that is at queue of 0. After this step, both the front variable and the rear variable are no longer -1. Next, we define the isFull function. All it does is return a 0 or non-zero value depending on the evaluation we place after return. Here we check if our rear variable is equal to size -1. If it is true, the function returns a non-zero value, and if it is false, the function returns a 0. Next, I add a printf inside the enqueue function just to show confirmation. This step is not mandatory. However, it does make your output more understandable. Let's now move on to our display function, which will display our entire queue. The code we've written up until now displays a front variable at the left hand and the rear towards the right, or in other words, our queue goes from left to right. I indicate this with the help of two printf statements, which I place before and after a while loop. The one before will show the front, and the one after a while loop will show the rear. In the while loop, we print everything in the queue from front to rear. Hence, we declare and initialize a variable inside, which we will use as an index. We initialize this variable with front as we start printing from the front. We print continuously while the index is less than or equal to our rear variable. After this, I check the output up until this point. I check if the enqueue and display functions are working. There is another thing we need to do inside the display function, and that is to only print if the queue isn't empty. Let's add that with an if condition and calling the isEmpty function. Since we need to print if it is not empty, we add a not operator inside the if condition. If it is empty, then we print that the queue is empty. Let's check the output once more. There seems to be a problem. The queue shows a 0 inside even though I never enqueued a 0 into it. This is because I called the isEmpty function inside the display function, but I haven't defined the isEmpty function yet. So let's go on and do that. The isEmpty function, similar to the isFull function, will check for a condition and return a 0 or non-zero value depending on the result. We need to check if both the front and rear variables are equal to -1. If they are, the queue is empty. else they aren't. I check the output once more, and our previous problem seems to be rectified. It displays the queue is empty instead of showing a 0. I'm going to now add a new line character before all my printf statements, so there is plenty of space after each print, and so that my output doesn't look all cramped up. Let's now move to the last part, which is the Dequeue function. We check if the queue is empty, and if it is, print a message telling that it is empty, and also return a -1 value. Remember, our Dequeue function is of type int, which means we will have to return something back to the main function. While dequeuing elements, we need to remember that when an element leaves a queue, it does so from the front, and the rear doesn't change. Hence, we save the data presently at the front of the queue to another variable, and should increment our front variable after checking a specific condition. We need to consider a special case where there is only one element left in the queue, or a case where we are trying to dequeue the last element. In such a case, we should not increment our front variable. Rather, we should set our front variable back to -1, as our queue is now empty. And since it's empty, we also don't have a rear element, so we set our rear variable to -1 as well. But how do we know that we have reached the last element? All we have to do is check if our front variable and rear variables are equal. If they aren't equal, we can increment our front variable, as it means that there are more elements in the queue. Finally, we return the value we had saved earlier. With that, our program is done. Now we just need to check the final output. Seems like I had 2 more errors, one for not using the structure variable, and another for not enclosing one of my if statements in curly braces. Let's now see the final output. Before we wind up this video, I would like to mention one more thing. If you remember, I said that a normal queue has a disadvantage. Well, here you can see what it is. Let's say I enqueued elements into the queue until it was full. So now there is no more space inside the queue. Also, our rear variable is equal to size -1. Now let me dequeue an element. So technically speaking, our queue should have one space available, as I just dequeued an element. However, because this is a normal queue, our program does not allow us to add a new element. This is because our rear variable is still equal to -1. And due to this, we can only further enqueue elements if our entire queue is emptied or dequeued. This disadvantage is taken care of in the next program, which is on circular queues. Hope you all understood. Thank you for watching. If it was of any help to you guys, please do consider subscribing. See you in the next video. Till then, take care.